On this lecture, we will introduce the chapter 4, section 3. It's the integration by parts. Parts mean 零件部分，所以翻译过来叫做分布积分法。好 this section has only one formula, so allow me to write down the formula. The formula is integral of u dv is equal to uv minus integral of v du. So let me prove the formula. The formula becomes in this way. In that semester, we have a product rule, like this product rule. The product rule is differentiate the two functions times together. Then we will get the gdff plus fdg. So in this method, integration became in this way. Capital D became D, F became U, G became V. So if you change this symbol, we will get the G D U plus U D G or U D V. Sorry, U D V. And from this equation, we move this term to the left. So D U V minus V D U became the equation, became the U D V. And then we change the position. U dv change it to the left hand side, and then these two terms change to the right hand side. So the equation became like this, and then we integrate both sides and each term to integrate, and then the formula became u dv is equal to uv minus integral of v du. So this equation, we call it change position. The u dv change into this way. Maybe the integration we can solve in this way. So the next film will introduce an example.
So we will solve the equation by integration by part. The example is natural log x dx. If we integrate natural log x dx, you will find in the table no formula like this. So we have differentiation formula like this. Differentiate natural log x is equal to 1 over x. And in this semester, we use the Leibniz notation for the differentiation. So the formula becomes like this. And then we move the dx as a differential of x. So the differentiate formula became 1 over x dx. So this differentiation formula is just like here. If you change the notation, u become natural log x and v become x. U become natural log x, v become x, and minus integral v become x, and the d become natural log x. So you will see uv change position. The u is x, and the v is natural log x. So we can write down like this: x times natural log x minus integral of x d natural log x. We can change it into 1 over x dx. So the change is corresponding to this differentiation formula, that is d natural log x is equal to 1 over x dx, 1 over x dx. So the problem is solved. Why is that? Because the x is cancel. So the integrand in the integral is 1 only 1. 1 is a constant. Constant integral of constant became x. So the problem is solved.
So let's see another example. Integral of x times e to x dx. How to integrate this one? The section 1 and the section 2, there are no formula for this. So we can try to use the integration by parts formula. That is u dv, integral of u dv is equal to uv minus integral dv du. So usually we see the integrand has two functions tied together. So you have to move one of these. But first we let u is equal to x. Then du is dx. And u dv, so we let dv equal to the e to the x power dx. And then we change the color, change it to the red. So if you integrate in both sides of the equation, we get the left, we get v, and the right hand side, e to the x, integral of e to the x is the same as the original e to the x power. So this v is e to the x, and then we can change the form, change as the u times v, u is x, and the v, we just get the v is e to the x, and minus integral of v is e to the x, and then du is dx, over here, du is equal to dx. So the original integral, using the technique integration by parts formula, is red formula, or red for the equation. We can do the thing like this. U is x, and the dv is e to x dx, and the formula says it becomes u times v minus integral v times du. Du is dx, it's over here, and the v is x, e to x. So it's not very complicated. You have to choose one of the function as u. In this example, choose u as x, and then the du is dx, or du is dx, this is du. So if this integral has the answer, then the whole example is solved. So this one, x times e to x minus e to the x, integral of e to the x is the same as e to the x plus c.